Live on WFLA Now. With a specialized degree in climate, Chief Meteorologist and Climate Specialist Jeff Berardelli is pioneering the way we look at climate and extreme weather. Welcome to Jeff's Climate Classroom, powered by ArmorView Window and Door.
All right, everybody, welcome to this week's Climate Classroom. And what we are talking about is the stunning and shocking heat of 2023. It was almost unimaginable to climate scientists how hot it got in 2023 globally. We're talking about the whole globe. We were all very surprised at how much further up the temperature climbed, how much warmer it was than we expected it to be. We expected it to be warm, but not that warm. All right, I want to introduce you to my guest this week, and you have seen her, I'm sure, many times on WFLA, or at least on this particular stream. This is Val Simpson. Val Simpson is one of our weather forecasters here in the WFLA weather department, and she's also climate curious.
That's right, Jeff. Thank you again for welcoming me to your show. I am thrilled to talk about this topic, really, because it's been headlines for the last week or so, and I have so many questions for you. So I hope you're ready.
I'm sure you do. I am ready for your questions. And by the way, just before we go any further, in case I go off on a tangent or get too technical, what happens?
I have my trusty buzzer with me. I'm going to buzz you just like that.
All right. Well, I deserve it, I'm sure, if you buzz me.
Yeah.
All right. So let's start out by, I'm going to put the graphic up that you asked me to make. So like 10 minutes before we went on air, Val's like, I'm not satisfied with the graphics.
No.
All right. So
I just feel that this actually paints such a good picture. I think comparing the two, it just tells, it explains a lot. So why don't you take it away? Tell me about that.
Sure.
What are we seeing? What are we looking at here?
Basically, I'm showing temperature anomalies. Now, for the folks listening to this on a podcast, you won't be able to see this, but it is quite stunning. I advise you to watch this in video. By the way, you can watch this on WFLA.com. You can watch it on our Facebook page. You can also watch it on YouTube once the episode is done. So on the left side, we're looking at 2023, and on the right side, we're looking at 1950, and we're looking at temperature anomalies. So I did a direct comparison between the 2 years. Where you see the blue, that's where it was cooler on Earth, and obviously most of the Earth was cooler in 1950 than it was in 2023, except for very small portions. You can see how on the left side, 2023 was just so much warmer than it was back in 1950. Now, on average, we don't generally compare. I'm going to bring you
it's shocking.
back up here. We don't generally compare one year to the other because there's a lot of natural variability. It's more accurate to compare like a group of years, maybe 2014 through 2023, compared to like 1950 to 1960.
Yeah.
However, you would see pretty much the same impact, the same effect.
Well, seeing all that red it just makes me, the first question I have is, how much warmer did we get?
It was 2.7 degrees Fahrenheit above the pre-industrial mean temperature. So back between 1850 and 1900, before we started warming the planet.
Okay.
2023 was 2.7 degrees Fahrenheit above that, about 1.48 degrees Celsius.
The thing is that when you say it like that, it actually doesn't sound like it's that much. Because, like, for instance, an anomaly would be, 10 degrees hotter than what we are today, or breaking a record, right? We were talking about that off air a little bit. And then all of a sudden, to see that it was 2.7 degrees, what does that actually mean, Jeff?
Well, 2.7 degrees would be like the temperature of your body, your fever going up, right? So our normal body temperature is like 98.5, let's say. So if it went up 2.5 degrees, then it would be, 101. So it'd be like having 101 fever. Now, let me ask you, Val, if you get up with 101 fever, how do you feel?
I mean, not well, not good, not strong, not healthy.
Right, you can't go to work.
No, definitely not.
You could get up, you could do the bare minimum. You could maybe cook for the kids, maybe.
No, I don't think so. With 101 fever.
But so it's kind of comparable to that, right? The Earth system is very sensitive. It's just as sensitive as our body system. So think about this. If we go up another degree Celsius or 2 degrees Fahrenheit, then we're at 103. Let's say we were to go up another 2 degrees Celsius, we're at 105. So, at 101, we can kind of function, not very well, but once we get to 103, then we got big problems. Now we can barely function. Once we're at 105, well, that's kind of almost getting to a death sentence, right? So it's somewhat similar. It's not an
Yeah.
exact comparison, but the idea is that the Earth system is just as sensitive to changes in heat as our body is.
And like, for us, we would see that kind of repercussion, right? We won't be able to get up. We wouldn't be able to go to work. What consequences would we see here, on Earth with these types of temperatures?
Well, we're already kind of seeing some of it, right? We're seeing the short-term impacts of it, which is this year we were almost 1.5 degrees Celsius. Scientists warned us about breaching 1.5 degrees. We'll talk more about that in a couple of seconds. But basically, we saw a lot of extreme weather, right?
Yeah.
More extreme weather than we've ever seen, not just in the United States, but all over the world.
Yeah.
Every year, that extreme weather ratchets up more and more and more. It was unbelievably hot and dry in the Amazon this year. You probably saw the pictures of the rivers drying up. That's partly El Nino.
Yeah.
But it's El Nino, which comes every few years on top of climate change. So you have climate change, which the temperature is going up and up and up and up and up, and then put El Nino on top of it, and now you push systems past thresholds in which, they begin to dry out. We have really bad droughts. Or, the same thing with storms getting stronger, floods getting worse. We had a ton of flooding in the Northeast this year, and some of it El Nino, some of it not. The warmer it is, the more moisture the atmosphere holds, and the more heavy rain that falls.
So El Nino, it's not something that we're going to see every year. It's not something that we're going to see next year or the following year. Does this mean that maybe these numbers could go down? Could we see... Since it's also a reason for, is that okay? Is that right? Because, I do believe that this year there's been so many initiatives, especially this year, 2023, so many initiatives in terms of fighting climate change.
Well, there's a lot of initiatives out there, but and there's stuff happening. Don't get me wrong. There's a ton of innovation happening. We're trying as fast as we can to ramp up solar and wind, but oil production has not fallen.
Right.
The amount of fossil fuels that we're burning, that has not generally gone down. Now, coal has gone down, but natural gas has gone up.
Right.
And oil production, we still, I think something like 80-something% of the primary energy that is used in the world is still fossil fuels. Yeah. So even though we're adding a lot of solar and wind and renewables, it is only let me try to phrase this the way that it makes the most sense. It's not replacing oil and gas. It is simply supplying the new energy demand, right? More people are going from being, less privileged, poor, to becoming middle class. And their energy usage goes up by like 15 times when you go from poor to middle class. So we're adding a lot of extra energy demand. We're filling most of that with new sources of renewable energy. But it also means that oil and gas, the use of oil and gas is not going down. I want to show you something, Val. I have this graphic up. I'm going to bring this graphic full screen. I'm going to go back to the last graphic real quick. And then let me show you the graphic and comparing 2023 to every other year since 1880. So there's 1880. You can see those temperatures go up. That's the natural trend of climate change. Not natural trend, because it's not natural. It's man-made. But that is the trend of man-made climate change.
Usually it's stack up nicely one on top of the other, but I see a gap, a black gap.
That's right. In 2023, it just went off the charts. That's why, we expected 2023 to be the hottest year or one of the hottest years on record because El Nino was evolving. And we knew it would probably be a strong El Nino and has been a strong El Nino, but we never expected it to spike the way it did. Now, it did spike starting in June. That is definitely telling because it tells us that it spiked around the time that El Nino was starting to get stronger. Now, we made a change from 3 years of La Nina, which locks heat in the ocean because it's cool in the tropical Pacific, so on the surface of the tropical Pacific. So you're not fluxing a lot of heat from the tropical Pacific into the atmosphere. And so La Nina locked a lot of that heat up for about 3 years. Then all of a sudden, we don't normally get 3 years triple dip La Ninas. All of a sudden, the La Ninas were gone, the 3 years of La Nina, and all of a sudden a strong El Nino burst on the scene. And a lot of that heat that had been locked up for years was fluxed out into the atmosphere. Even with that said, the jump that we saw in 2016, which was substantial, the last strong El Nino, 2023 was a lot more substantial in terms of the jump that we saw in global temperatures than it was in 2016. I can tell you the 2016 El Nino event was stronger than this particular El Nino event we're having right now. This one's a strong one, but not as strong as 2015, 2016.
Wow.
Yeah.
Wow. So that would be the last. So we're okay. So 2016 was the last or the last second to last.
There was
Hottest
a weak El
year.
Nino. Oh, you're asking? Yes, that's right. Yeah, so let me go forward. I have other graphics to show you, and I think you'll be able to see it right here.
Let me see.
So let me pull this graphic up full for you. So you can see that the last 10 years have been the 10 hottest years on record on the globe. Okay.
Wow.
And it just, but notice how it doesn't go in order.
It doesn't.
2023 is clearly the hottest by a long shot, about
Yeah.
0.3 degrees Celsius.
Mm-hmm.
So it's about a half a degree Fahrenheit above the record,
Yeah.
which was set back in 2016. That is a lot. To set a record by that much globally, it's not just one little city.
Yeah.
It's globally. Everything's averaged together. But notice 2016 is the second hottest year on record, and that's because of the El Nino.
And both those years we were, an El Nino. Got
That's
it.
right. So we expected it, Val. We expected 2023 to be hot. We just didn't realize it would be off the charts.
This hot.
That's right.
Yeah. I mean, what were scientists expecting about what's the range that they were thinking that we were going to get to? Maybe stay below 2 degrees above the average before industrialization?
Right. Okay. Well, that is a good question. So why don't we just talk about the Paris Agreement then? Because you're bringing up questions about 1.5 and 2 degrees.
Yeah.
Okay. So first question was, you asked, what did we expect? We expected if we were going to break a record in 2023, we expected to break it by that much, not that much. So basically we expected to break it by a little or maybe not at all. It was very close. We knew it was going to be real close. The beginning of the year, I think the percentages were, there's a 20 or 30% chance, and I'm making those numbers up, but it was there was a 20 or 30% chance that we would break the record for the hottest year ever. But as the year went on and we saw, how hot it was, those percentages went up. And by October or November, there was like a 99% chance we were going to be the hottest year on record.
Yeah.
And sure enough, it was by far the hottest year on record. Okay, so you wanted to know about the Paris Agreement and 1.5 and 2 degrees Celsius, right?
Yeah, because I want to understand that. I want to understand. Tell me more about the Paris Agreement. How did this come up? And, who sounds the alarm on this?
Well, all the scientists in the world. So there are thousands of scientists that have been working with the IPCC, which is the Intergovernmental Panel on Climate Change. It's an international organization. And every few years, they make a big report with all the latest scientific data and the status of climate change. And obviously, the status is that we are continually warming, and the warming hasn't slowed. If anything, and it's an if, it may have accelerated to some degree. Some scientists think that warming has been accelerating. Others think it's been steady as she goes. But either way, it's still going up.
Yeah.
And we haven't done anything to stop it. In 2015, all the countries came together in the world. All the countries signed the Paris Agreement, saying that we would do our best to limit warming underneath 1.5 degrees Celsius, or if we couldn't do that, 2 degrees Celsius. So just for the folks at home who do stuff in Fahrenheit, and most of us here in the U.S. do stuff in Fahrenheit, 2 degrees Fahrenheit is almost, it's almost 4 degrees. It's a little less than 4 degrees. Excuse me, 2 degrees Celsius is a little less than 4 degrees Fahrenheit. You multiply it by, you kind of multiply it by 2. Actually, you multiply it by 1.8. We don't want to do the math here. But the bottom line is, so 2 degrees Celsius is like 3 points. That's right. You stay away from math.
Yeah.
2 degrees Celsius is about 3.6 degrees Fahrenheit, I think, if you do the math on it. So all the countries came together and says, we're going to endeavor and do our best to keep temperatures below 1.5 degrees Celsius compared to the pre-industrial temperatures. Pre-industrial would be before we started burning fossil fuels, releasing greenhouse gases, those greenhouse gases trapping all that extra heat and warming the Earth's system. So you compare that to like 1850 to 1900. So we did not want to exceed 1.5 degrees Celsius of what the average temperature was back between 1850 and 1900.
So scientists were expecting that there was going to be an increase, but they were hoping that it was going to be under 1.5.
That's right.
Am I understanding that correctly?
Barely underneath 1.5 this year. That's a really good, good analysis there. It was barely below 1.5 degrees Celsius. Now, why is 1.5 important? Why is 2 degrees? Well, first of all, it's kind of arbitrary, right? Scientists said, all right, when do we expect to really see the extreme weather and the other impacts of climate change really ratchet up? Well, our computers tell us at around 1.5 degrees, things just start to get much worse.
Yeah.
And beyond 2 degrees, they get much, much worse, right?
Yeah.
So we almost got to 1.5 this year, and I'm going to bring up this graphic to show you. So this is from the good folks at Copernicus, which is the European weather, essentially, and climate monitoring agency. And and for the folks at home who are watching, you often times will hear me talk about the European model on television, right? Well, these are the folks who make the European model. Okay. So this graphic right here shows every single day of 2023 with a dot.
Yeah.
And it shows what the temperature was on that day relative to 1.5 degrees or 2 degrees Celsius above pre-industrial temperatures.
Yeah.
You can see that the first half of the year, we spent most of the year between 1 and 1.5 degrees Celsius.
Yeah, that was pretty good.
So we only breached it a little bit.
It seems like in March we breached it a little bit, right?
That's right. But then all of a sudden in the summer, and then especially in the fall, we were breaching 1.5 every single day.
Wow.
And 2 days during November, we breached 2 degrees Celsius. Oof. Now, I say that we breached it, but in truth, we haven't breached the Paris Agreement. First of all, we were only 1.48 on average for the year. We didn't quite reach 1.5, but it's kind of semantics. Right. And the other thing is, in order to be considered a true breach of the Paris Agreement, you need to be 1.5 degrees Celsius above pre-industrial temperatures for many years in a row. Yeah. It can't just be 1 year. So even if we got to 1.5 this year, it wouldn't technically be considered a breach. But we're pulling the wool over our own eyes. We're trying to fool ourselves by thinking that, well, we're not going to say that a breach is, if we breach it for a year or two, we're not going to call that a breach. We're going to only call it a breach when we've done it for 10 years in a row. Well, that's just making ourselves feel better about the situation, when in reality, we're very close. Probably less than 10 years from now, probably the early 2030s, most scientists believe we will breach 1.5 and we will always be above 1.5, meaning that the summer of 2023 will be normal in about 5 to 10 years. And then, or the whole year of 2023, that will be normal for the globe in about 5 or 10 years. And then by 2040, it will be considered a cool year on Earth.
Oh, my goodness.
And the extremes that we saw in 2023 will be considered minor compared to what we're going to see in 2040 or 2050. And by 2050,
I can't even imagine.
By 2050, we're likely to reach 2 degrees Celsius if we don't really do some big work right now.
Yeah.
And when we do, or if we do, but it's likely we will, then our extremes will be that much worse. It's hard to imagine what they'll be, but they're going to be a lot worse than they were this year.
Well, this year, definitely not only temperatures, atmospheric temperatures were high, also sea surface temperatures. So when we're referring to 2023 being one of the warmest on record, we're talking about everything, both things, right? The temperature of the water.
Yeah. So I'm going to bring you up right here, and I'm going to bring up the graphic that you are requesting. Let me bring that up and bring it full so people can see it. So, one of the things that I think was most eye-opening about 2023 was just how hot the water was. Now, if you follow weather here in Florida or you follow hurricane season, you know that we kept talking about how hot the Atlantic was. Also, by the way, the tropical Pacific was warm because it's El Nino. And when you look at the globe on average this year, take a look at 2023 compared to every other year there. And thank you, Ed Hawkins, for this graphic. But you can see how when you compare the ocean temperatures to the average ocean temperatures between 1970 and 2000, so like 20, 30, 40 years ago, you can see the red on the right side. The temperatures of the oceans have been going up, basically each and every year, on back and forth, up and down. Right. But the trend is upward. But take a look at how much warmer the oceans were in 2023 compared to the next warmest year, which was probably 2016.
Yeah, absolutely. Like, that's a big jump. And we know what that means.
It's a very, very big jump.
If those water temperatures are warm, that means that it's going to be fuel for storms and hurricanes. Yeah, and we did see that because initially they were predicting that it was going to be just slightly below average as far as the hurricane season. And then as soon as the updates started coming in, it was going to be an average. And then we saw that it ended up being an above average season. So
El Nino was able to mitigate that a little bit. So we know that El Ninos typically mean less hurricanes in the Atlantic Ocean.
Yeah.
We had a lot of activity this year, but a lot of it was weak. It wasn't all weak, but a lot of it was weak activity. A lot of the stuff was pushed out to sea. It didn't really affect us.
Storms.
Yeah, we had Idalia early in the year, but generally speaking, even though it was an active season, I think it would have been a whole lot more active, crazy
didn't have-
active, if it wasn't for El Nino. So El Nino helped, but it goes to show you that it doesn't look good for the future, right? If even even a strong El Nino cannot combat the water temperatures and the effect from climate change of a warming ocean in the Atlantic, if El Nino cannot combat that, it always was able to.
Yeah.
Last decade, the decade before, but it no longer seems to be able to compete. It can reduce the number of hurricanes during El Nino, but it no longer can bring it below normal, I would say. And going forward, those water temperatures are only going to warm more. And El Nino is going to have less and less of an impact, likely because of that. I mean, I can't be sure about that, but it seems likely. So again, that graphic that I'm going to show you one more time, those are ocean temperatures, and you can see how from the 1800s onward, water temperatures have been warming, especially starting in the 1970s, which makes a lot of sense. And then, we didn't talk about exactly why. Well, first of all, we should talk locally here for a second. Anybody watching us from Tampa? Tampa's 9 out of 10 of Tampa's hottest years have occurred in the last decade. And 2023 was around 3.6 degrees Fahrenheit above normal. We had extremely hot summer with so many days above 90 or 95 degrees. Yeah. So we are feeling the impact of that here in the Bay Area.
And also a very dry summer too, Jeff.
That's right. And that was one of the reasons why it was so hot this summer. For here in the Tampa Bay area, it wasn't just El Nino, it wasn't just climate change. We had a weird local pattern going on, and we don't know exactly why. We had a westerly flow so often. We don't know if that's a trend going into the future, and it may have something to do with climate change. We don't know the answer to that. But I can say the localized westerly wind that we had forced all the storms to the east coast of Florida. But even in places where it rained a lot, Miami, it was by far the hottest year on record.
Also,
even there.
Even with all that rain.
Right.
So why is this happening, Jeff? What's going on? Why are we seeing such drastic jumps in these temperatures?
It's a good question. So let me first bring this graphic up and talk about what El Nino means. So there are two reasons, right? Climate change has been raising the temperature each and every year, and the trend is upward, okay? So that's the base. The base temperature starts higher. Then whenever you get an El Nino, which happens every few years or so, and this one happened to be a strong one, well, that warmer water, which, by the way, is essentially in touch with the atmosphere. They communicate, if you will. That warmer water fluxes heat into the atmosphere. And that heat gets distributed around the Earth. And so it ends up being, and you can see, looking at that map right there, these are water temperature anomalies, okay? Yeah. So where is it below normal? Where is it above normal? Well, it's not really below normal almost anywhere. There's a little bit here in the Eastern Pacific North.
Yeah,
right?
I see that.
But the equator, where El Nino is centered, you can see how it's really warm. It's about 4 degrees Fahrenheit on average in the El Nino region, above normal right now. And that heat gets transported from the ocean into the atmosphere, and that causes extra warming during El Ninos. So the reason why 2023 was really warm was, number one, climate change has caused global temperatures to go up around a little more than 2 degrees Fahrenheit over the past 100 years. And then add on top of that, like a layer cake, El Nino adding that extra heat. But even that, and you read the article, and by the way, folks, I'll just, I'll bring this up.
Plug it in, plug it in.
Yeah, we're going to plug it. If you want to read more about this and the reasons behind why it was so hot in 2023, go to our website, and you will be able to probably find it on the homepage, WFLA.com. But if you're listening to this later or watching this later, go to the weather section and go to Jeff's Climate Classroom, and you'll see the article about how 2023 was so oppressively hot. There were other reasons, Val.
Yeah.
We don't know exactly why, though. What I mean is that if you do the math on climate change, and then you add to it El Nino, it still doesn't get you to the temperatures that we experienced in 2023.
Yeah.
We there's a missing piece, maybe a few tenths of a degree.
Yeah.
So we think that maybe some of that is the reduction of pollution and aerosols, especially in the North Atlantic Ocean.
Yeah.
And you
Can
asked
you
a question.
explain to me about that? Because I didn't understand. Because I said, well, if we don't have that layer, then that means that more sun is getting through. Right. And you said that's part of it, but there's more to it. Can you expand on that?
Sure. So pollution mass the atmosphere to some degree, which you mentioned, and it allows less sunlight in. So that's number one. That's really easy, right?
Yeah.
So if there's less pollution, more sunlight gets in. Okay. But in addition to that, pollution acts as cloud nuclei. So essentially, you cannot condense water vapor, invisible humidity in the atmosphere. You can't condense it unless you have something to condense it on, like dust, like salt from the ocean that's suspended in the air, like pollution.
Yeah.
Those act as nuclei, and then the water vapor will then condense like that on a nuclei and form raindrops or cloud droplets. So with less clouds, because there's less pollution in the atmosphere, you have less white in the sky, right? Clouds are white.
Yeah.
They reflect sunlight back to space before it gets a chance to be absorbed by the Earth's system. But if you have less condensation nuclei, you have less clouds, you have less white, and you have less what we call albedo or reflectivity. Okay.
I know you were gonna. Albedo deserves a. We're gonna buzz you on that one. Okay.
Right. But albedo is reflectivity. So how much the Earth is reflecting. And by the way, Earth's reflectivity has been going down over the past 20 years, which is likely due to a decrease in cloud cover, which is likely to due to a decrease in pollution. So we passed the Clean Air Act back in the 1970s and 80s, and it has really cleaned up our act here in the U.S. The U.S., guess where the U.S. pollution goes when it's done with us? When we release it here in the U.S., where does it go? It travels with the jet stream into the Atlantic Ocean. So if you have less pollution over the Atlantic Ocean, what happens to the Atlantic Ocean?
Less pollution gets warmer.
It gets warmer. The Atlantic has been warming. It's not just due to human-caused climate change from the burning of fossil fuels and the release of carbon dioxide, greenhouse gases. It is also due to the fact that we are cleaning up the atmosphere. Now, you might say to yourself, well, hold on a second. There was no pollution around 1800, right? So then, therefore, it should have been just as warm in the Atlantic. Well, what's happening is we have been steadily warming the Earth for the past 100 years because of climate change, because of greenhouse gases, right? At the same time, we were releasing a ton of pollution in the 1950s, 60s, and 70s that was going over the Atlantic.
Yeah.
So we were masking the greenhouse effect. We were preventing it from being detected because all that pollution was counteracting the greenhouse effect, right? Like now we clean up the atmosphere, we take all that pollution out, and all of a sudden we're exposing all that pent-up decades worth of greenhouse gas, fossil fuel, climate warming.
Yeah.
And thus we've seen that increase in acceleration of temperatures, especially since 1980. Now, at the same time, the Western Pacific has been cooling a little because China has been producing a lot more pollution, or at least that was the case a few years ago. And as a result, they've seen a decrease in the number of tropical cyclones, at least several years ago to a couple of decades ago in the Western Pacific. But in the Atlantic, we've seen an increase. So it's not just due to the burning of fossil fuels and the release of these greenhouse gases and the human-caused climate change signal. It's also due to the reduction or increase in aerosols, depending upon which part of the world you're talking about, whether it's China or the U.S. China's starting to clean up its act as well. But we cleaned up our act first, and they industrialized after us, so their pollution came after we did. So anyway, it gets a little complicated, but
it almost seems like there needs to be like a healthy balance of pollution.
But unfortunately, see, that's the thing. Pollution kills about 8 million people per year. So if you increase pollution just so that you can reduce the amount of warming, then people die of pollution.
So how do we offset it?
Well, first of all, we just have to stop burning fossil fuels, right? Or slow it down. That's number one. That's something we can do almost now if we really put our minds to it, because we have the technology, solar, wind, and batteries, all the alternatives. It takes a while. It's not going to happen tomorrow. It takes decades for it to happen. But that's the first thing we can do. In the longer term, we can suck carbon dioxide out of the atmosphere, carbon removal. But that's really hard, and it's really expensive, and it hasn't been proven at scale.
Plant more trees.
What? Oh. Planting more trees. That's a great. Did you say planting more trees?
I did.
Okay. Yeah. Planting more trees is a great suggestion. Yes, the more trees we have, the more carbon dioxide that we suck out of the atmosphere, the cooler it gets, or the less warmer. It gets. Problem is we have limited land. We have 8 billion people living here on Earth.
Right.
So we have to figure out how to better utilize our land. And so much of the reason why we have cleared so much land in the world, including especially the Amazon, is for industrialized meat production. So it's not just the grazing of cattle. It's not. Were you gonna buzz me?
This is
we getting too deep?
We're getting way too deep
You think
here.
so?
Don't make me feel that. Every time I come to your show and you start talking about that, I'm like,
Well, you should have let me go, and then you could have buzzed me.
Okay, I'm sorry.
Okay.
Go ahead. So tell me about it.
Well,
So
no,
they're
we're
clearing
using
the land
to grow food for cows, for livestock, not just cows, but livestock. We're using a ton of land for that. And we're clearing old growth forests. Those old growth forests were really, really good at sucking in and storing carbon dioxide. So we no longer have a lot of those forests to suck in the carbon dioxide.
Yeah.
And so that remains in the atmosphere. And a lot of it has to do with animal agriculture. We're meat eaters. We eat meat. And because of that.
Well, you don't.
I don't eat meat. That's true. I don't eat meat. Yeah.
Yes, but we do eat a lot of meat. I myself included. You know that every time that we have this topic, I can't. That's the one thing that I even said once I hit a certain age, I wanted to go vegetarian, and I can't do it.
It's tough to do.
I can't do it.
Well, I had no choice. I mean, my wife cracked the whip, and I just
love
followed. My wife
Christy.
was like, "I'm not." She's like, "I'm not eating meat." She it's a long story. She just realized how brutal it is to be an animal in animal agriculture, and what they see when they know they're about to meet their demise. You see video of these animals, and they know.
I can't hear this,
and it's really sad. And plus, they're all cramped in very tight quarters and stuff like that.
Jeff.
No, anyway, look, I don't ever go on and on about people stop eating. I never tell people
I know
you have to stop.
You
I don't do that.
You don't do that.
You got to do what you can
but,
do. Do whatever you can.
I
to
have
help.
feelings. I have a heart. You start talking like that, and
Sorry.
I'm gonna start looking at my roast beef a little bit different.
Yeah. So do you think we answered all the questions out there? Is there anything that you think we left out?
No, I think that you were very thorough. I learned a lot, and I am very happy that you actually were, willing to go down this this rabbit hole and talk about all the things 2023 and why it was the warmest year.
Yeah, it was a stunner for people like me who've been doing this a very long time, and for honestly, even the best climate scientists in the world are really debating whether we've entered a regime change. Meaning, did we tip the climate somehow, and all of a sudden, instead of temperatures going up like this, all of a sudden now they're going up like that? Is there a pivotal point that we reached this year? Are we going to see accelerated warming? There's a bunch of scientists who believe that, and then there's a bunch of scientists, and these are the best climate scientists in the world. You could almost have like a steel cage brawl between these climate scientists. Because honestly, you never see climate scientists necessarily disagree. They're mostly in line with each other because the research supports that. But this year, scientists are just debating not is it warming, but is it warming much more than we thought it would, or are we starting to enter a phase of accelerated warming, or are we still just steady as she goes? And it's tough to know for sure. But it was shocking for many climate scientists.
As a last thought, what do you think we should take away from this, from knowing that 2023 was the warmest year, and it could probably in 10 years it might just become normal or average what we're seeing today?
It is. What do we take away? We take away that good intentions and greenwashing are not going to change our fate. We are fooling ourselves if we really think we're doing enough to slow this. This is, some people call it the climate crisis or climate emergency. I tend to avoid those words because I tend to think of an emergency as like your house is on fire or someone's very sick in your family.
Yeah.
But I will say that if we don't do something very soon and we don't get serious about this, there's so much pushback against climate action. But really all we're trying to do is save ourselves from a world of hurt in the future. I'm not a climate alarmist. I don't really worry about much of anything. Val, do you ever see me really worried about anything?
I really don't. I love your chill attitude here at the office.
I'm very interested in this. I'm intellectually interested in climate change. It is fascinating to me. Am I worried and alarmed? Maybe a little worried. Not very alarmed. I'm not an alarmist at all, but I will tell you, you should be getting alarmed. If we don't respond as a society to this almost immediately, it could be very alarming what we face in the future. And I say that, we're in pretty good shape, Val, right? We have a good economy here in the U.S. now, and I'm not talking about now. I'm talking about relative to other countries that are a lot poorer.
Sure. Yes.
we are going to weather the storm a little better, but it is going to impact us a lot in the future, and our kids especially. So, they're already experiencing life or death situations because of climate change in developing nations right now.
Yeah.
We may or may not get there in our lifetime, Val, but I think if we don't do something soon, our kids and grandkids certainly will have to face that.
Yeah, and that's the hardest
You asked
part.
me a last word. I give you a last 1,000 words, whatever.
I love that. I love that. I love
Yeah.
to finish off on that note.
Well, again, Val, I want to thank you for joining me. These are always some of the most fun shows for me, so I appreciate it.
Thank you, Jeff. It's always a pleasure.
And I just want to remind everyone that you can tune in to this Climate Classroom on our website or various different places. So once this whole episode's done, the next minute, we'll package it up. We'll send it to YouTube. Also, this can be listened to on Spotify and Apple Podcasts as well. We try to do it once every week or once every 2 weeks. You can also, of course, watch it on our Facebook page. I want to thank you for joining me today, and I'll see you again in a week or two for Jeff's Climate Classroom. Thank you.
Watch or listen to Jeff's Climate Classroom, powered by Armor View Window and Door on WFLA social media platforms, and find Jeff's climate reports on WFLA.com.